Good afternoon, everyone. Oh, give me 1 second here. I was about to start, but it looks like we got someone here. Good afternoon, Cynthia. How are you doing?
Good, I'm good. How are you?
Doing well. So, Cynthia, you're actually the only person here live right now. Um, I just want to clarify with you kind of how you would most like this to go. Um, you know, obviously I could ask you questions and we could go back and forth if that's something you wanted to do, but also Um, if if this sounds better, I could also just kind of work through the problems and let you interrupt me anytime you have a question. Which of those kind of two formats do you think would work better for you?
I think the second one.
Okay, well, we'll do that, but please interrupt at any time. Okay.
Okay,
All right. So the first thing I just want to say before we start on any problems is that these questions are not necessarily meant to be all the types of questions that could appear on the exam. So first off, let me just share my screen and remind you that if we go and click on the chapter 1 exam block, that in the islands questions, underneath here is a list of topics, as well as the assignments that you'll find those topics in and the page numbers and the notes that you'll find them in. So let me just give you a real concrete example here. This notion of understanding the difference between observational studies and experiments. On this particular set of practice questions, I don't have a question that directly asks that. But of course, I have it listed here as one of the things that you need to make sure you understand the difference in. And so that's all just to say, I think that the questions I do today will be really helpful. I tend to pick questions that are ones that students tend to need a little bit more practice on than maybe others, but that doesn't mean that content that doesn't appear in this set of practice questions, isn't fair game for the exam. So I just wanted to make that really clear before we got started. The second thing I want to make clear is that the islands questions here are completely different than the questions that we're going to do together. So here's the first question that we're going to do together. You can see a histogram and it's yellow. But if I click on the islands questions, completely different histogram. So the idea here is that we're going to do these practice problems together, and then hopefully that'll build your confidence in going in and doing those islands questions to help prepare even more for the exam. So in other words, these islands questions here are an assignment where you can go back in and say, all right, let me really make sure that I'm understanding, what we did in the review, and kind of go from seeing me doing problems to making sure that you can do the problems yourself. So, so Cynthia, just real quick before I do move on, since you are here, do you have any questions about that?
no.
All right. All right, so let's dive into these practice questions here. On this first page, oh, and by the way, just real quick, this is for you too, Cynthia, just in case, but in the review session recording, which does not have a video yet, but will shortly, here's the document that I'm going through. So practice questions PDF, and that's what we're going to do together. So you can have that.
Oh yes, I already downloaded and tried to
Excellent.
practice.
Awesome. Wonderful. Yeah. Just making sure that everyone seeing the video didn't forget where to find this. Wonderful. All right. So one of the things we really need to be able to work with is a relative frequency histogram. Okay. And so remember that a relative frequency histogram, that word relative means that we're keeping track of the proportion of the data set that falls within a certain range. And it's easy to spot a relative frequency histogram compared to just your traditional frequency histogram because you're going to see decimals along the vertical axis. So the moment that I see decimals there, I know that this is a relative frequency histogram. And so I think part A will help us really make sure we're understanding what this is all about. It says, suppose that employees of a company were asked to estimate the number of emails they respond to in a typical week. The relative frequency histogram above displays this data. So part A, what proportion of employees answered between 60 and 70 minutes per week? So this gives us directly information about the proportion. So I look at the height and I do my best to just kind of trace over here, see about how high it goes. My best guess is that this is about at 0.11, a height of 0.11. And so that tells me the proportion. So I could answer this question by saying, since here's 60 and here's 70, and this down here is always our variable of interest. That's always our horizontal axis. And so this is going to be number of emails per week. I can answer that and say 11%, because I think that that's about the height that that histogram bin goes up to. For parts B, C, and D, I think what we're going to find helpful here is to be able to scroll down, but so I'm just going to go ahead and copy this so I can get it all in one screen. Just gonna move this right about here. A little smaller though. All right, so now it's asking me about quartiles and percentiles. So in part B, it asked me to estimate the first quartile of the data set. So the first thing we need to remember is that the first, second, and third quartiles divide our data set into quarters. So the first quartile, that's the cutoff for the first 25% of the data. So that means that this is also known as our 25th percentile. And similarly down here in part D, when it asks for the median is the data value that's right in the middle of the data set, meaning 50% of the data is below that value, 50% is above. So that's the same thing as my 50th percentile. And so to determine this, we need to use this relative frequency to figure out essentially how far into the data set we need to go in order to hit the 25th percentile, the 60th, and the 50th percentiles. So as we go along, what we just want to do is, first of all, estimate these heights. And these estimates don't have to be perfect. But as you saw in some of your earlier homeworks, you just have to be in the ballpark. I'm going to call that one about 0.01 or 1%. I'm going to call this one about 0.03. And if you made different estimates when you tried this yourself, that's okay, as long as we're pretty close to the same estimate here. This one seems a little short of 0.2, so I'm going to call it 0.19. This one here, let's call it 0.25. And then maybe 0.22, right? And then this one here, we'll call that about 0.10. Now, I was just estimating all of these here, but hopefully if I add them all up, I'll get 100%. Let's see if that's the case. 1 plus 3% is 4%. So that's going to be, if I add on 9, 13%, then I'll have what, 32% and 57%, 79%. Yeah, 90%, 100%. So it all adds up to 100%. If we add up all these proportions, it adds up to 1 or 100%. So that's good. Now, if I was off a little bit, it wouldn't have been a big deal. Obviously, I'm estimating these heights. But the other thing we want to do, if we're going to try to figure out these percentiles, it's also helpful not only to have the relative frequency, which I show in green with these heights, but also to keep track of the cumulative relative frequency. And so remember, that means that you just add things up as you go. So what I essentially was just kind of doing in my head to check my estimates there, I'm going to add up 1% plus 3% would be 4%. And then if I add that 4% to that 9%, I get 13%. Add those two together and I get 32%. Add these two together and I get 57%. Add the 57% plus this new 22% and I get 79%. Then 90%, and then 100%. So there's our cumulative relative frequency. So in order to estimate first quartile, 60th percentile, 50th percentile, I want to make sure I'm understanding what these numbers are telling me. And so let me just write out a statement here that isn't necessarily an answer to any of these three questions. Let me just write out this statement. I'm going to say this. The 13th percentile is 30 emails per week. The 13th percentile is 30 emails per week. I can see that 30 along the horizontal axis is going to be right here. And this represents the number of emails per week, or whatever variable we're interested in. So the fact that after I get through to 30 emails per week, I've had a total of 13% of the entire data set fall somewhere in here, then that must mean that about 13% of the data is 30 or below. And that's what a percentile is, right? It's the 13th percentile is the value at which 13% of the data is below that number. So the reason that that's helpful to make that statement is now I know what I'm looking for, right? If I want the 25th percentile, then I'm not quite there yet. When I got to 30 emails, I was only at the 13th percentile. So I could write another statement based on this next spot where one bin ends and the next begins. We could say that the 32nd percentile is 40 emails per week. Okay. Now that's a larger percentile than I was shooting for. So we know that 32% of the data set is 40 or below. We know that 13% of the data set is 30 or below. So that would have to mean that the 25th percentile has to be somewhere between 30 and 40, right? It's got to be somewhere in here. That cutoff point where 25% of the data is below has got to be smaller than the 32nd percentile, but larger than the 13th. So in a case like this, I don't really care too much how you say it. if you want to say, you could just say it like this: between 30 and 40 emails per week. That's your 25th percentile. Or you could actually give me an estimate, right? You could say, you could actually say, 36 emails per week. And obviously that would be a guess. If someone else said 34 emails per week, I would mark that as correct as well. So you just have to give me an answer that's somewhere in this range of values. Okay, and I don't care too much exactly how you write that out. I just want to pause, Cynthia, did you have any questions at this point before we do C and D real quick?
No.
Okay. And so we can continue to play this game, right? So the fact that I just made note of the 13th percentile and the 32nd percentile, I could just keep this up, right? So I know the 57th percentile has to be about 50 emails per week, right? Because once I get to 50, I can see that a total of 57% of the data is at 50 or below. So the 57th percentile is 50 emails per week. And so we haven't quite made it to part C, but I guess we can go out of order here and do part D. Since we know the median is the 50th percentile, since 40 was the 32nd percentile and 50 was the 57th percentile, our median has to be somewhere between 40 and 50 emails per week. And then lastly, we weren't quite to 60% when we were here. I'm way over 60% once I get to 60 emails per week. So the 60th percentile must be somewhere between 50 and 60 emails per week. Okay. So that's all you have to do if you're working with a relative frequency histogram and I ask you questions like these, is understand what the height of the histogram means, and that if you want to see in total what percent of the data set is below a certain value, then you're just adding up the different heights, as we did here. 0.01 plus 0.03 is 0.04. Add that to 0.09 to get 0.13, right? So that meant 13% was at 30 or below. So that's the way you answer these questions. And just remembering that the first quartile is the 25th percentile, the median or the second quartile is the 50th percentile. And then just for good measure here, before we leave this behind, if I ask for the third quartile, let's remember that that is the 75th percentile. Same thing. All right. In this second problem, what I'd like to do is now look at a histogram that's not a relative frequency histogram, but just a regular frequency histogram, meaning it's telling me how many data values are in each range. Okay. This told me the percentage of the data set that was within each interval of the variable. This is telling me how many values in the data set. All right, and I think like that last one, we're going to find it a lot more helpful if I have a copy of this to look at side by side. So we'll do that. Okay. So it says data was collected for a sample of organic snacks. The amount of sugar in each snack is summarized in the histogram below. So how many snacks were analyzed in this study? So first it asked me for the grand total, okay? Well, that would have not been a possible question for me to answer in the last problem, right? In the last problem, all we knew were the percentages that were in each interval. But here, since I know the actual number, then I can just look at the height and notice that, okay, 3 snacks had a sugar content between 60 and 62 milligrams of sugar. 5 here, 9 here. And so we can just literally add these up. Okay. And so when I do total these up here, 3 plus 5 is 8, 8 plus 9 is 17, 17 plus 12 is 29, 29 plus 11 is 40, 45, so it looks like 47. So adding all the different heights of the histogram bins up, there were 47 snacks. And now we're going to estimate the percentiles, just like we did in the last one. So the first one asks for the 40th percentile, okay? In a relative frequency histogram, the heights themselves are already proportions. So I'm trying to figure out where does 0.4 fall in the histogram. But here I can't do that because the heights represent the actual number of data values. So in a regular histogram, what we have to do then is we have to answer the question, what is 40% of the grand total, 47? Okay. Now, I don't need you to write this sentence out every time, but you need to know that that's what it is that you need to calculate. But as we've talked about, 40% of 47 just means I'm taking 0.4 times 47 and making that calculation. And what I get there is 18.8. And remember that this is giving us an indication of how far into the data set to count in order to get to the 40th percentile. And remember that the thing we have to remember is that we're not necessarily rounding here, we're just going up to the next whole number, okay? So even if this was 18.1, I would do the same thing. I would use the 19th data value. Use the 19th data value. That's how far into the data set I need to count. So I can look and say that at 62, I've gone through 3 of the data values. Once I get through 64, I've gone through 8 of the data values. Once I've gone through 66, I've gone through 17 of the data values. So I'm almost there, but I need to use the 19th value. So probably the 19th value is not that much more than 66. But I don't know exactly where it is, but I do know it's got to be somewhere between 66 and 68. I know that because after I'm finished counting through the amounts of sugar that are below 68, I'm all the way up to 29 values. And the value I'm looking for is the 19th. So again, you could give an estimate, but I would just count anything correct that's between 66 and 68. Or you could just write it out like this. You could say between 66 and 68 milligrams, just like that. And then the same thing goes for the 90th percentile, right? I got to figure out how far into the data set to count. So what's 90% of 47? Well, that calculation gives me 42.3. But what it tells me to do, again, this is not like true rounding. I'm just going up to the next one. We're going to use the 43rd. Use the 43rd value. And there, I'm gonna have to count for a while. Once I get through 70, you can see that that's, I'm through the 40th data value. Once I get through 72, I'm through the 45th data value. So that means the 43rd data value's got to be somewhere between 70 and 72. So again, I could simply say between 70 and 72 milligrams. And then on the third quartile, I mentioned this on the last page, kind of jumped the gun. We could have waited till now to discuss it, but remember this is the 75th percentile. So the 75th percentile. And so I need to say we're taking 0.75. Oops. There we go. 0.75 times the total. And when I do that, I get 35.25, which means let's use the 36th. Use the 36th value. And I'm going to find that 36th value between 68 and 70, right? We're through 29 at 68, we're through 40 at 70. So somewhere between 68 and 70 is when we get through the 36th value. All right, so if we're moving on from histograms here, Cynthia, just want to check in. Anything you need me to pause on or expand on more?
No.
Okay. Here's just the one thing I just want to point out for everybody who's going to be watching this later. This step right here, where we're calculating the percentage of the total, this is only a necessary step when you have a regular histogram. Notice that when you look back here, we didn't do anything of the sort. Why? Because we already had the heights of the bins in terms of proportions or in terms of percentages. So it was easier to spot the various percentiles. Whereas here, they're harder to spot. So that's the reason why we need that extra calculation. Okay, so moving on to box plots. Okay, I want to be able to, it's important that we can answer questions about box plots. And I think maybe the best thing I can do here is to just put a copy on top and on bottom. Something like that. All right, so in number 3 here, it says the website Hoops Hype published salaries of NBA players. So the 2009-2010 salaries of players on 5 teams were used to construct the comparative box plot. So which team's salaries has the largest interquartile range out of the ones listed here? Okay. So interquartile range, remember, is a way of measuring the spread of the data, but it's just the difference between the first and third quartiles. So in other words, it's how spread out is the middle 50% of the data. Okay. So in a box plot, let's just remind ourselves of the basics here. When you have a box plot, starts at the low, ends at the high, but then the left and right edges of the box are first quartile and third quartile. And then this line in the middle, that's the second quartile or the median. So the interquartile range, IQR, the interquartile range, that's just the difference between Q3 and Q1. All right, so I could go through and try to calculate all these, but I don't need to do that because it just asks for which one's the largest. And clearly, the Denver Nuggets have the first quartile and the third quartile being much further apart from each other than any of the other teams do. So we'll just say the Nuggets because the box part, I guess I could say, the box part of their box plot is largest. All right. Part B. So true or false? If the player with the median salary for the Knicks is traded to the Grizzlies, he will be one of the highest paid players on the Grizzlies. All right. So remember, median is just right in the middle, right? The person who makes the middle amount of money for the team. So what's happening here? The person was on the Knicks and they were at the median. So that means they were right here. Right? There's the median for the Knicks. They get traded to the Grizzlies. Right? We can see that, yes, they should be one of the highest paid players on the team, right? This would definitely be true. Okay? And it's true because his salary is well above not just the median, but the 75th percentile, right? Here's the 75th percentile for the Grizzlies, is well above the 75th percentile. For the Grizzlies salaries. Now in part C, we're going to consider just the Lakers for a moment. So suppose that 40% of the team makes between $5 million and $15 million. About what percent of the team makes more than $15 million? Okay, so we're looking at only the Lakers here, and they're saying, first of all, 5 million to 15 million. So they're saying that in here is 40% of Laker salaries. Okay. So they're wanting to know, here's the highest Laker salary up here, I guess. So they're wanting to know what percent is in here. So answering a question like this just means we've got to make sure we understand what the different parts of the box plot tell us. Okay? We know that a box plot breaks things into quarters, as we said before. So since each part of a box is 25%, that means that in the case of the Lakers here, if I'm thinking about, let's see, what color should I use? Let's use green. This green portion right here should be 25%. And then this green portion right here should be 25%. So in total, between the two, that should be 50% of the data set for the Lakers. So since it's 50% total, and we've already used up 40% between 5 and 15 million, it must just be that there is 10%, right, in this question mark region right here, 10% of the team. In part D, which team's salaries have a higher standard deviation, the Lakers or the Knicks? Okay. It doesn't really help that I drew all over this, so let me erase this from the previous question for a moment. So we're looking at the Lakers and the Knicks, and we want to know which one has the higher standard deviation. Okay. Remember that standard deviation is also a measure of spread, just like interquartile range, right? The higher the standard deviation, the more spread out it is. Now, we don't have to actually use a formula or anything like that for this to answer this question, because we've got Lakers and Knicks, right? So here's the Knicks. Here's the Lakers. Okay. First of all, overall, the data for the Lakers seems to be much more spread out. But even going beyond that, it's not just this outlier that's causing the spread to happen. The Lakers are also more spread out in their box as well. Okay. So we can see that the Lakers will have a higher standard deviation because there is more spread. In the data. All right. And that's all I'm looking for there. So, what's it that I'm trying to see if you understand? I'm trying to see if you understand that the standard deviation, that thing we've been calculating, that's a way of measuring spread. Okay. So that's all I'm asking you to look for in one like this. All right. Now we're looking at just the nuggets for this last question. So consider the nuggets. Do more players make $5 to $10 million or $10 to $20 million? So let's mark these. So in yellow, 5 to 10 million. That puts me from here to here for the Nuggets. And then 10 to 20 puts me from here to here for the Nuggets. All right. Now, the answer to this question is 10 to 20, but I want to be very clear about something. It is not because 10 to $20 million is a larger interval than 5 to $10 million. That has nothing to do with it. What it has to do with is how much of the data set can we say is contained within each of those intervals. Okay. So, yes, the answer is 10 to 20 million. But the reason is because more than 25% of the team earns in this range, right? How do I know that? Because I know that each part of the box contains 25% of the data, right? Just a quick sketch here. Just a random box plot, right? This is 25%, this is 25%, this is 25%, and this is 25%. So the fact that I am taking up the entire top part of the box plot, that's 25% right there, just in that arm. And the fact that I'm going below that for the 10 to 20 million and scooping up some of the data that's actually in this third quarter tells me, it's got to be more than 25%. Whereas less than 25% of the team earns $5 to $10 million. And how do I know that? Because I know that there's 25% in this third quarter And I've clearly not even encompassed that with 5 to 10 million because of how large of a range that third quarter takes up. Okay. So when you're asked a question like this, you can't always calculate, or often you can't calculate exactly what percentage makes within each of those intervals, but you can make statements like, well, it's got to be more than 25%, or it's got to be less than 25%. You should be able to make those types of statements to decide which one has more. All right, Cynthia, any question on that one before we do the last example?
No.
Right. So the last one's going to have us work with a contingency table. Here's another one where I think I will snap a picture of this table. I'll put one down here as well. All right. So it says it shows a random sample of musicians and how they learn to play their instruments. They had that broken down by gender identity. So the thing we want to look for in these is for clues as to what type of probability question they're really asking us. Okay. So let's kind of work our way through these. I'll make little comments as we go. It says, what proportion of those sampled were self-taught? Now, one of the things that you might find helpful, and I believe I talked about this in the notes, is to kind of have this thought experiment of imagine that you have all 130 people in a room. And when you go through and you ask the questions, you can imagine actually being in the room and asking the question and asking people to maybe raise their hand. And you can think about in each question, all right, am I asking everybody this question? Am I only asking a small group of people this question? And that'll kind of help you sort out what the fraction should look like that's going to produce your answer. So when it says, what proportion of those sampled were self-taught? I imagine myself in the room with these 130 people, and I'm not asking any special group this question. I'm asking everybody this question. Hey, raise your hand if you were self-taught. So the fact that I'm asking everyone means that the number 130, the grand total, that should be my bottom number. And then how many were self-taught? Well, we have all these different numbers for self-taught broken down by gender. However, we didn't ask about gender, right? We just asked, out of the 130, raise your hand if you're self-taught. Well, you're going to get females, males, non-binary. You have everybody raising their hand if they were self-taught. So how many raised their hand? 31. So it's just simply me taking this number out of this number. And as far as writing the answer, right, 0.238, if you want to write it as a proportion, that's fine, meaning the decimal form. Or if you want to write it as a percentage, that's great. 23.8%, move the decimal over 2 places. What are the chances, part B, what are the chances that a randomly selected person from this sample is a male who had private instruction? Okay, so what does that mean? Well, what are the chances of a randomly selected person from this sample? Okay, so again, as I'm asking this question of the group, I'm asking everyone, right? All 130 people. But this time, I'm asking them to raise their hand if they are a male who had private instruction. Okay, so not everyone who had private instruction raises their hand. Only the males who had private instruction raise their hand. So this time 14 is my top number, but 130 is still my bottom number. This one is really an and question. The chances that someone is male and they've had private instruction. Okay. Part C, what proportion of females in the sample received private instruction? Okay, now here's where we got to be careful. When I ask this question, am I asking the entire group? It says, what proportion of females? So at this point, well, I'm about to ask the question, but I'm going to say, okay, first, this question is only for females. Right? That's what I'm going to declare at first. So you can even imagine in our big room where everybody's in, say, females, can you step over here? Right? And let's imagine, okay, how many females stepped over to the side to have me ask the question? Well, there's 70 of them. So now when I ask the question, it's not out of everybody, it's just out of the 70 females because I already know the person's a female. Then in that small group of 70, I ask, okay, how many of you received private instruction? Well, 22 out of the 70, right? So I only want to look at the 70 females and 22 of them on private instruction. So put that in my calculator. Oops, it's 0.314 or 31.4%. In part D, what is the probability that a randomly selected person from this sample either studied music in school or received private instruction? Okay. So let's see. Are we asking the entire group? Well, what is the probability that a randomly selected person from this sample, okay, not a randomly selected male or female or non-binary, so we're not specifying gender here, right? So we're asking everyone once again. Received either studied music in school or received private instruction. Okay, well, we can see that 62 studied in school and 37 total received private instruction. So that's 99 out of the 130 people. So 76.2%. This is what's known as an OR probability, right? What are the chances of one thing or another having occurred? Now it says, what is the probability a randomly selected person to the sample is either male or was self-taught? Okay, so another or, okay? Or here and or there. Okay, so we're still asking everybody, but now it says male or self-taught. Well, we can see that total there's 56 males. And there are 31 who are self-taught. Okay. But here's the type of OR probability where we have to be a little bit careful. We have to ask ourselves, when we ask this question, did anyone raise their hand twice? Right. So I said, so raise your hand if you're male. Okay. And that's when we saw 56 people raise their hand. Raise your hand if you were self-taught. 31 people raised their hand. But did anyone raise their hand for both questions? And the answer is yes. There were 18 males who were self-taught, and we counted them twice. We counted them in both groups. So we need to remove them, not remove them in the sense that we don't want to count them, but we only want to count them one time. So knowing that we've counted them twice between these two groups, we got to correct for that and take those who are both male and were self-taught. So in one of the OR probabilities, we had to subtract off, and the other we didn't. And remember that what's the difference is that studying music in school, receiving private instruction, those were what we call mutually exclusive, right? People had to put themselves into one category or the other. They couldn't be in both at the same time. Whereas male, the gender, and the whether or not they were self-taught, those were not mutually exclusive, right? You could be both male and be self-taught. And so that's why we had to make that correction. And then part F, what are the chances that a person who was self-taught is male? Okay, let's go back to that original question we've been asking ourselves throughout. When I ask the question, am I asking the entire group or a smaller portion? Well, what are the chances that a person who was self-taught? Okay, so we already know the person is self-taught. So that means instead of out of 130, this is just going to be out of the 31 people in the room that are self-taught. Then we say, all right, how many of you are male? 18 raise their hand. So it's 18 out of 31. So Cynthia, for you, any questions? And it could be from this, or if there were just any other questions that you had that you thought of that I didn't necessarily address in any of these problems that you wanted to ask.
No.
So let me just leave things here. If I go back to this, and I just keep emphasizing this bulleted list here. So what's, just from having taught this class many times, a temptation for students might understandably be to focus more on the math related questions, which I also did, right? I kind of did a lot of the math related questions where you're using graphs and numbers and things like that. Okay. And those are important to practice, but don't neglect things like, do I remember what a population is and what a sample is and a variable, data, parameter, statistic? Like those are important pieces of vocabulary. And if you recall, one of the things that we did do was we took situations and we said, okay, in this study, what is the population? What is the parameter? What is the statistic? So make sure you go back and have a good handle on all that vocabulary, right? Similarly, I started with this, but talking about things like sampling techniques, observational studies, and experiments, right? So those questions weren't so much math questions, right, as they were, do we understand what the definition of an observational study is? Do we understand what the definition of an experiment is? And what observational studies can tell us and not tell us, and experiments as well. So just don't neglect to go back and really feel comfortable about those. Some of those concepts will show up in the islands questions, but make sure you go through this bulleted list and look at each topic and say, okay, yeah, I feel comfortable with the types of questions that were asked in the homework of me, and that we went over in the class notes. So just don't neglect those things. And then the other thing I'll just say is, just as a reminder, you can pick either Wednesday or Thursday to take the exam. You take it here on WAMAP. There's a password that the test proctors will enter for you. But again, you will receive that piece of paper that I talked about in the video last week that has places for you to write your workout. Okay. Now, let me just be very clear about this. And I guess in the same breath, I'll be kind of giving something away, but I don't think it's a big surprise. You'll probably have some sort of question that has a table in it like this. And I might ask you similar types of questions about that table. Is this something that you could just type in your calculator, right, and never write anything down for? Well, yeah, of course. It's not like it's overly complicated, right? You could look at this table and say, oh, 31 and 130, and just type it directly in your calculator. But you need to write down this fraction here, okay? Because I do give partial credit. So if all I see is a number that's incorrect, I've got no partial credit to give. If, however, I see a fraction and there's a 130 on the bottom, but a 62 on top instead, then I can give you credit for the fact that you understood 130 was the appropriate bottom number to use, even if you messed up on the 62 part. So even something as small as writing the fraction down, right? You want to do that for your own interest so that you make sure that if you're off a little bit, you'll still, at least get some credit if you understand a lot of what you're doing in that problem. So if the problem is shown on the piece of paper that they hand you, write down your work, right? Even if you don't feel the need to do it anyway. All right. Cynthia, I'll just bug you one last time. Any questions from you after I went over those things?
No,
All right.
good.
Thanks for coming by, and of course, for any of you watching this recording later, if there's anything that I did on here that didn't, that you want to follow up on, it's really easy just to shoot me a message saying, hey, I still need a little bit of help with 2C. I didn't quite understand why you did those steps. And so questions like that are great. You can send me those in a WAMAP message, or just you can start a new thread in the homework forum. I'll be happy to answer those for you. All right. Thanks, and have a great day.
Thanks, you too.